For the first part of the lab, I've copied this MATLAB script from the link provided in the lab report, and I didn't have to change anything for it to function correctly, but basically what it's doing is it's simulating how a capacitor will charge based on 5 volts and based on the resistor that's put in front of it. So here it has a 10 kilo ohm resistor and a 100 kilo ohm resistor, and these 4 loops are going to help us find the values at each time and also at each resistance, and this is going to create 2 different lines on the same plot. And so when we run this is what it looks like. And one thing to note is that this blue line, which is 10 kilo ohms, is that charges a lot faster and it gets to that peak almost about a second in, whereas the red one, which is 100 kilo ohms, takes about 5 seconds to get to that same fullness. And so for the experimental part of our lab, this is my Arduino code, and basically it correlates with this circuit that I've created, which is just a 10 kilo ohm resistor, a capacitor, and 2 wires that connect to analog pins, ground, voltage. And so what this Arduino code does is it defines the capacitor, the resistance, finds tau, and figures out what the delay should be for it to delay each serial print by tau over 50. And so what I did here was analog write the pin 3, which is what my voltage source is connected to, and it writes it as 255, which is the highest, so it'll send 5 volts, and it'll read the values of Vs and Vc every tau over 50 milliseconds, and then it'll print those values, and then it'll do that 500 times until we reach a time of 10 times tau, and then it'll switch and do low values of voltage source at 0, and it'll do that all over again and switch back and forth. So if we run this and look at the serial monitor, we can see it'll be frozen for a second because we did that 5,000 millisecond delay at the beginning, and then we'll see that our data is showing up. On the left side, sorry it freezes, but on the left side we have our voltage source, 0 and 1023, it's alternating between 0 and 5 volts, and on the right we have our capacitor voltage, it's frozen again, but those are just the values of the voltage in the capacitor. And so we can transfer this data into our processing, and basically what processing does is takes that data, it transfers them into these integers, A1 and A2, and it graphs them, based on an X value, which just increases each dot. And so we can see it's kind of like what we did with our Etch-a-Sketch and stuff. So it takes a while at first, and then it'll start to show. We have our voltage source, which is red, and it's only on that 0 volt line and that 5 volt line, and then we've got our capacitor voltage, which charges and discharges. So at the end of this processing code, I've had it saved, this data saved to a table called ENME351 Lab5 10K newest, and so after moving that code into a MATLAB folder, I can open that up in MATLAB using this MATLAB code, and we get a graph that looks like this. And so we'll look at that in a little, but first I want to talk about my MATLAB code. And so basically what it's doing is it's extracting the different columns of the data that we've put in, it's defining them as Vn and Vc, and it's just going to plot those over time. And so this is what our plot looks like. And I'm going to do the same thing for the 100 kilo ohm, and then we can compare them, and then compare them to our simulation data. MATLAB code, I've changed it to 100K newest, and I've changed my R value up here to 100K. We can run this and see what our data looks like, and it's looking good. So we can do a side-by-side of our 10K and our 100K just to really see what's going on here. So on the left is 10K, on the right is 100K, and basically one thing that's really noticeable at first is this one, it takes 8 seconds to run, this one took 30 seconds to run and only shows about 2 peaks, whereas this one shows about 4. And so that just goes to show that this, with 100K resistor, takes a lot longer to charge that capacitor. And similarly, it takes just as long to discharge that capacitor. And so we can look at our simulation data, and that roughly follows what we found in our MATLAB simulation. And even interestingly enough, this one also, we said that it took about 5 seconds for the 100K resistor circuit to charge completely, and that looks about right. 20 to 25 seconds, we're getting that full way to the peak, whereas this one takes about 1 second to get to that peak. So the results match up pretty accurately with our simulation, so that's really great.